this lesson, we're going to talk about scientific notation. Scientific notation is the way that scientists easily handle very large numbers or very small numbers. So I have some examples to kind of show you what it looks like to have a number in standard form and to put it into something called scientific notation. So if you look at this first big number that we have here, the number is in standard form. This is just a regular number, but I don't know about you, but let's say that I had to write that number multiple times. I probably would not really want to write it that many times because it would take so long. So what scientists do is they write it in a shorthand kind of method, which we call scientific notation, which is what you see here. Now, this number that, this first number in red that you were looking at is a really big number. But scientific notation also works for really little numbers like the one down here. This number is a teeny, 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 tiny little number. And I know that because it has a decimal in it. And you see this teeny tiny little number, this number can also be written in scientific notation because I don't know about you, but I don't want to write this tiny number a million times. There's too many zeros and I'd probably lose track of them. So some things to know about scientific notation. So positive exponents, they mean that it's a large number. So again, our number in red, our big number, like the number that we probably want to see a dollar sign in front, yeah, it's a big number, so it's going to have a positive exponent. And then our tiny little number, it has a lot of zeros in it, and it's going to be a negative exponent. So negative exponents mean that you have a small number. Now, one thing to make very clear is that exponent number that we're looking at is not how many zeros there are. That is not what it means. I am going to show you what it means in a moment. Another thing to know about scientific notation is that whenever you're putting it into that form, you can only have one number in front of the decimal place, or at least to the left of the decimal place. So you can see in my two examples that I have the number 7 and I have the number 5. You can only have one number before the decimal. So if you had something like 10.4, that would be two numbers before the decimal. So you can't have that. You can only have one digit. Okay, let's go ahead and let's look at our first problem. We want to convert these numbers into scientific notation. One thing to know is that all four of these numbers, they are in a form called standard form. Standard form is just they're in their number form. So let's go ahead and let's convert these all into scientific notation. I like to ask myself a couple of questions as I'm doing this. I first like to look at my first number and I want to ask myself, is it a big number or is it a small number? Meaning, would you want this amount of money put into your bank account? So this first number, I'm going to say yes, this is definitely a large number. Okay, well, if it's a large number, does that mean that my exponent is going to be positive or negative? We said earlier that large numbers create positive exponents. Okay, now we want to know, are we going to move our decimal to the left or to the right? Well, I'm going to show you here in a moment what we're going to do. But right now, I'm going to tell you that we're going to be moving it to the left. How many spaces? Well, let's go ahead and find out. So I have my number here, and you'll notice that there are no decimal spaces between any of the numbers. When that occurs, I always want to assume that my decimal is at the very end of the number. Now, I want to move that decimal between the 8 and the 4. I want to move it all the way to here because that would give me that one number to the left of my decimal point. So let's go ahead and count the spaces between the first dot and my second dot. So I'm going to count 1, 2, 3, 4, 5, 6, 7. 7 spaces. Okay, so now let's go ahead and let's write our number in scientific notation. I'm going to take my first two numbers, 8 with a decimal 4, just like I have written. I'm going to use the little times symbol, and then I'm going to say times 10 to the power of 7. 7 came from the number of spaces it took me to get from the decimal all the way between the 8 and the 4. And remember, I can only have one digit to the left of the decimal, and that's why I knew that I needed to move it to between the 8 and the 4. Okay, let's try another big number. All right, so I just answered that. This is a large number, which means I'm going to have a positive exponent. I'm going to move my decimal. I'm going to move it to the left because remember, I don't have a decimal, so I'm going to put it right here, and I need to move it to the left. How many spaces? Well, let's go figure that out. I have a 932. I can only have one number to the left of my decimal, so I'm going to go ahead and move it all the way over there. And now I'm going to count my spaces. 1, 2, 3, 4, 5, 6, 7, 8 spaces. Notice how I did not count the zeros. My number wasn't 6, my number was 8 because I'm counting the spaces. All right, so 9, I'm going to put my decimal place in, and I'm going to write 3, 2. I always finish with the last number that I'm given, and the last number I was given was 2, and then the next number comes as 0. So 9.32 times 10 to the positive exponent because it's a big number. All right, let's look at some small numbers and let's see how they're different from each other. Okay, so this next number is small, and I can tell that it's small because it has a decimal in it. So I'm going to circle small number. Small numbers always have negative exponents. In this case, I'm going to move my decimal to the right. Let's go figure out how many spaces. Here's my decimal. It's already there. I want to move it all the way between the 4 and the 5 because I want 4 to be to the left of my decimal. So let's go ahead and count. 1, 2, 3, 4, 5, 6 spaces. There it is. So how I'm going to write it is going to be 4.5 times 10 to the, now careful here because now I have a negative exponent because it's a small number. So I'm going to say 10 to the negative 6th. All right, let's look at another small number. Very small because it has a decimal in there. Small numbers mean negative exponents. I'm also going to move my decimal all the way to the right. Let's count out how many spaces. I want it to go. I want the 9 to be the only digit to the left of the decimal. So this is where I'm going to move him to. Let's count how many spaces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 spaces. All right, so my number is going to be 9 point. Now, usually when I have 9 point and there's not a number following it, I can always say, 9.0. That's just another way of saying 9 times 10 to the, it's a small number, so I'm going to say negative 10th power. So this was moving from standard form into scientific notation. Now, what we're going to talk about is going from scientific notation to standard form. Let's go ahead and look at our number. Let's look at the scientific notation that we have here. We have 6.4 times 10 to the 5th power. And I want to know, is this a large number or small number? We know that it's a large number because of our exponent. Our exponent is positive, so this is a large number. And again, our exponent is positive. So we want to know which direction are we going to move our decimal. Well, the number 6.4, I want to make this number a big number. To make this number a big number, I need to move my decimal to the right. How many spaces am I going to go? Well, my exponent tells me how many spaces I'm going to go, and I'm going to go 5 spaces. So here I have my 6.4, and I'm going to move it 1, 2, 3, 4, 5 spaces, and that's where my decimal is going to go. Now, all these little loop-de-loops, I'm going to fill in with zeros. This is going to be my number. Again, it's a big number. It's a number that you would put a price tag on. So my final number is going to look like this. And instead of putting a decimal at the end, I'm going to consider putting commas. So this is going to be my standard form of my number that I was given. Let's do another one. 8.32 times 10 to the 8th power. This is a large number because I have a positive exponent. Now, I want to move my decimal to the right because I want to make a large number. How many spaces? Well, look at my exponent. That's going to tell me 8 spaces. So, I'm going to go ahead and write 8.32, and I'm going to move it to the right 8 spaces to make it a big number. 1, 2, 3, 4, 5, 6, 7, 8. I'm going to go ahead and fill in all those loops with zeros. And this is going to be my number. But I don't want to write it like this. I want to rewrite it as 8, 3, 2 with 6 zeros. I'm going to go ahead and put my commas in there. And that is going to be my big number. So if you think about it, I could actually take this number that I'm putting a box around, and I could translate that into scientific notation again by doing the method we did before. We're just converting back and forth between the two. Okay, now that we've looked at 2 big numbers, let's look at 2 small numbers. All right, I know that this is a small number by looking at my exponent. It's a negative number, so that makes it small. Now, to make a small number, I need to move my decimal to the left this time. So let's go ahead and figure out how many spaces. I'm going to write my number 4.22. And I'm going to move my decimal 6 spaces to the left. 1, 2, 3, 4, 5, 6. All right, I'm going to go ahead and I'm going to fill in my zeros. Now, remember what my small numbers looked like. They actually had the decimals inside them. So I'm going to write it as 0 or my decimal 0, 0, 0, 0, 0, 4, 2, 2. That is my small number represented and converted from scientific notation to standard form. Another small number. I know it's small because of my negative exponent, and I know that I'm moving to the left. Let's see, 1.2. Let's move him 1, 2, 3, 4 spaces. And we did 4 spaces because of our exponent. So let's go ahead and put our zeros in there. There it is. Decimal 0, 0, 0, 1, 2. There's our answer. Okay. Now what we want to do is we want to answer some of the questions that we are given here. It says, circle the largest number in each set. So I know there's a lot of numbers to look at, but let's just look at the first set of 4 numbers. We want to determine which is the largest. We can determine which one is the largest just by looking at the exponents. Because don't we say that negative exponents are small numbers? So looking at the first set, can I take that second one with the -5 and that fourth one with the -4 and cancel them out? Because we know that they're tiny, tiny numbers. Then we look at our exponents 3 and 6. 6 is much bigger than 3, and therefore that is going to be our largest number in the group. Okay, looking at the next one. Looks like the same thing. Look at our exponents. We want to know which one of these exponents is the largest exponent. Well, clearly the first one is going to give us the largest exponent. So that's going to be our largest number. Okay, in the next set of numbers, this is kind of unique because look at our exponents. All of our exponents are the same. That means that we can't determine which number is the largest with our exponent. We actually have to look at our base number. These are our base numbers. If we can't determine it using our exponents, we have to figure out which number is the biggest base. And we can see that 9.6 is the biggest base number out of the 4 that we have. Okay, let's look at the next one. Again, look at our bases now. They're all the same. Doesn't really matter because we need to look at our exponents. 2, 10, -5, and 6. They're all different. So in this case, we can just look at the largest exponent, and that is going to be our largest answer. All right, the next one, we have one of those ones where the exponents are identical. So we can't look at those exponents anymore to tell us if it's the largest. We have to actually look at the numbers. We have to look at these base numbers. We have to figure out which one's the biggest. It looks like 7.8 is our biggest one. And then the last one, again, we have the same exact exponents. So we can't look at the exponents to tell us which one's the largest. We have to look at the base number. Now, all these base numbers are pretty similar. Look at our 7s. They're all the same whole number. So let's go ahead and look at the first number next to the decimal to the right. We have 5, 3, 1, and 2. Because the 5 is the largest, this is going to be our largest number. And the last thing we're going to do is we're going to put the following numbers in order from least to greatest. So now we're trying to figure out which one's the smallest all the way up to the largest. So let's go ahead and look at the first one. Let's focus on the base number because look, the exponents, they're all identical. And again, when they're identical, we cannot determine which one's the largest because of that. So let's go ahead and look at our base numbers. Which one looks the least? Well, it looks like 3.14 is going to be our smallest number because 14 is smaller than everything else that we see. Then 3.26 times 10 to the 8th. Then 3.3 times 10 to the 8th. And then finally 3.6 times 10 to the 8th. All right, let's go ahead and focus on the exponent now. All of our exponents are different. So we can determine which one's least all the way to the greatest just by looking at the exponents. The smallest exponent is the least one, which is going to be 2.2 times 10 to the -8th. The next one is going to be 2.2 times 10 to the -2, going up on my number line. My next one is going to be 2.2 times 10 to the 4th power. And then coming in at my greatest number, it's going to be 2.2 times 10 to the 6th. The last set of numbers, let's focus on the base number and the exponent. Neither are the same. So none of my exponents are the same. None of my bases are the same. So I kind of have to look at both of them. I'm going to start by looking at my exponents. My least exponent is going to be my -9. So 6.8 times 10 to the -9. Then I'm going to do my 5.6 times 10 to the -5. 6.8 times 10 to the 3rd. And then my last one is going to be 6.18 times 10 to the 7th. All right, that is our lesson on scientific notation.